fascinating concepts of space curvature and space acceleration. These ideas might sound complex, but trust me, they're incredibly intriguing and can change the way you think about the universe. You might have heard that massive objects like planets and stars bend the fabric of space, creating what we know as space curvature. This bending is what gives us the force we experience as gravity. This idea comes from Einstein's theory of general relativity, which beautifully explains how gravity works. Einstein revolutionized our understanding of gravity by showing that it's not just a force between masses, but a result of the curvature of space-time itself. Picture a heavy ball on a trampoline causing a dip. That's space curvature. The heavier the object, the deeper the dip, and the stronger the gravitational pull. But wait, there's another intriguing concept, space acceleration. This idea adds another layer to our understanding of how objects move through the cosmos. Imagine you're in a rocket, traveling through space. You might think you're moving in a straight line, but according to general relativity, the space around you is curved by nearby massive objects. So, even though the rocket moves in what seems like a straight line, the curved space makes it feel like you're curving around these massive objects, much like a car turning on a winding road. This is a crucial point because it shows how our perception of movement is influenced by the curvature of space itself. Now let's tweak that perspective. Instead of just thinking about space curving around massive objects, let's consider the idea that space itself can have an acceleration rate. Imagine space expanding, causing its position to change over time. This expansion isn't just a passive stretching, but an active process that can influence how objects move. As space expands, it changes the positions of objects within it. This means that as you travel through space, you're not just curving due to gravity. You're also accelerating because space itself is changing. This concept is like being in a car that not only turns but also speeds up. The acceleration you feel isn't just from the car's engine, but also from the changing road beneath you. Think of it like this. When you're in a car, you feel the momentum as you accelerate. Similarly, as space expands, it changes the positions of objects within it, giving a sense of acceleration. This acceleration isn't from space curvature, but from space itself expanding. It's a dynamic process that adds a new dimension to our understanding of movement in the universe. This acceleration isn't from space curvature, but from space itself expanding. It's a dynamic process that adds a new dimension to our understanding of movement in the universe. And here's a cool analogy. Think about magnetism between two similar masses, like repelling magnets. This creates an invisible push force. Magnetism between two similar masses, like repelling magnets, creates an invisible push force. This is similar to how energy and electricity work. You don't see the force, but you can feel its effect. You don't see the force, but you can feel its effect. In the same way, space acceleration is an invisible force impacting how objects move. In the same way, space acceleration is an invisible force impacting how objects move. It's a subtle but powerful influence that shapes the dynamics of our universe. So, to sum up, while space curvature explains gravity through the bending of space by massive objects, space acceleration provides a different perspective. It suggests that the expansion of space itself causes changes in position and momentum. This dual understanding of space curvature and space acceleration gives us a richer, more nuanced view of the cosmos. Keep exploring, stay curious, and never stop questioning the universe. The more we learn, the more we realize how much there is yet to discover. If you enjoyed this explanation, hit that like button, subscribe, and share it with your fellow science geeks. Thanks for watching. Your support helps us bring more fascinating content to you. Catch you in the next video. Until then, keep looking up and wondering about the mysteries of the universe.